Welcome to Behind the Product. Before we begin, this documentary is created strictly for educational and informational purposes. The industrial machines and factory environments shown are operated by trained professionals under strict safety regulations. Please do not attempt to replicate any of these processes at home. If you're passionate about discovering how the products you use every day are truly made, subscribe now and turn on notifications. Today, we are going deep inside one of the largest cassava processing factories, where a simple root becomes food, industry, and survival. Long before machines start running, long before conveyor belts begin to move, the story of cassava begins quietly underground. In vast fields stretching beyond what the eye can see, cassava plants stand tall under the heat of the sun. Their green leaves sway gently in the wind, but beneath the surface, something powerful is forming. Thick, starchy roots expand slowly in the soil, absorbing nutrients, storing carbohydrates, preparing for harvest. Cassava is not rushed. It takes 8 months, sometimes 10, sometimes 12. It survives harsh weather. It grows in poor soil. It waits. Farmers walk through the fields inspecting the leaves. Yellowing signals maturity. The stems are cut, and hands grip firmly at the base of the plant. With a strong pull, the soil breaks open. The roots emerge, heavy, solid, coated in earth. This is the moment where agriculture meets industry, because cassava cannot wait long after harvest. Within 24 to 48 hours, deterioration begins. That urgency drives everything that follows. The harvested roots are gathered into piles and sorted immediately. Soft spots mean rejection. Pest damage means rejection. Rot means rejection. Only strong, firm roots move forward. They are loaded into trucks, sometimes stacked high, sometimes transported in bulk containers. Engines start. The journey to the factory begins. As trucks approach the massive processing facility, the scale becomes clear. This is not a small operation. This is industrial food production. Gates open. Security logs arrivals. Each truck is directed toward a weighing station. The weight of the harvest is recorded carefully. Payment to farmers depends on these numbers. Accuracy matters. The unloading process begins. Tons of cassava roots spill onto receiving platforms. Workers wearing protective gear begin another round of inspection. Even after field sorting, quality must be confirmed. A single bad batch can contaminate thousands of kilograms of product. The roots are fed onto large conveyor belts that slowly carry them toward the first mechanical stage. The washing unit is loud and relentless. Giant rotating drums tumble the cassava while powerful jets of water spray from every angle. Mud washes away. Stones drop through metal grates. Debris separates. Water flows continuously, filtered and recycled in modern facilities to reduce waste. Cleanliness here is not cosmetic. It protects the integrity of the entire supply chain. Clean roots move forward toward peeling. The brown outer skin must be removed completely. It contains natural cyanogenic compounds that can release harmful substances if not processed correctly. Industrial peeling machines use abrasive rollers that scrape away the tough exterior. The sound is sharp and mechanical. In some sections, trained workers stand along the line with knives, trimming away stubborn patches. Precision is important. Remove too little and risk contamination. Remove too much and waste valuable starch. The freshly peeled roots, now bright white, move immediately to size reduction. Large mechanical choppers slice them into smaller pieces before entering industrial graders. Inside these machines, high-speed rotating blades shred the cassava into wet pulp within seconds. What was once a firm root is now soft mash. The transformation is dramatic and irreversible. The pulp falls onto collection trays below. Moisture content at this stage is extremely high, sometimes over 60%. The smell is fresh and earthy. From here, the process begins to branch depending on the product being manufactured. Some pulp is transferred directly into fermentation sacks or stainless steel fermentation tanks. This stage is critical for products like Gari and fufu. Over 1 to 3 days, natural microorganisms begin breaking down compounds within the mash. Bitterness reduces. Toxic elements are neutralized. Flavor develops. Temperature and duration are monitored carefully. Fermentation is controlled chemistry. Other pulp skips fermentation and moves straight toward pressing. Hydraulic presses apply enormous pressure, squeezing water out of the mash. Liquid drains away through filtration systems. The remaining pressed cake becomes firmer, denser, more stable. Removing water is essential. Without it, drying would take too long and spoilage would occur. The pressed material passes through sieving systems that break apart clumps and remove fiber. Vibrating screens ensure consistency in texture. Uniformity is crucial for commercial food products. Fiber byproducts are collected separately. Nothing is wasted. Many factories convert leftover fiber into animal feed or organic compost. Drying follows next. In traditional settings, sun drying might be used. But inside a large industrial factory, mechanical dryers dominate. Heated air circulates through enclosed chambers, gradually reducing moisture to safe storage levels around 10 to 12%. Sensors monitor temperature constantly. Overheating can damage starch structure. Underdrying risks mold growth. If Gari is being produced, the dried fermented granules move into massive roasting pans. Workers stand for hours stirring continuously with long wooden or metal paddles. The granules heat evenly, turning slightly golden and crisp. The aroma changes. Texture shifts. Roasting defines the final character of Gari. Skill here cannot be automated completely. Human judgment matters. For flour production, dried material is sent to fine grinding mills. Heavy steel rollers crush and pulverize it into soft white powder. The flour is sieved repeatedly to guarantee smooth texture. High-grade cassava flour must meet strict standards, especially for baking applications and gluten-free markets. For starch production, another system operates simultaneously. The wet pulp is mixed vigorously with water to release starch granules. The slurry passes through fine filtration screens. Starch settles in large tanks while lighter fiber floats away. Excess water drains off. The starch cake is collected and dried rapidly in flash dryers. The result is ultra-fine white starch powder used in food, textiles, paper, pharmaceuticals, and adhesives. Meanwhile, peeled roots may also be sliced into chips. Mechanical slicers create uniform pieces that are dried and packaged for animal feed, export markets, or industrial ethanol production. Cassava is versatile. One root feeds multiple industries. As finished products approach completion, automated packaging lines take over. Machines weigh precise quantities into bags. Air is removed. Bags are sealed. Labels are printed with batch codes and expiration dates. Large sacks are stitched and stacked onto pallets. Quality control officers take random samples for testing. Moisture analysis. Microbial tests. Texture checks. Documentation ensures traceability. In the warehouse, finished goods are stored in dry, ventilated conditions. Inventory systems track distribution. Trucks line up once again, but this time they carry finished products outward, to markets, supermarkets, export terminals, and distribution centers. The journey that began underground now moves across cities and borders. And this is only the beginning of the full story behind cassava processing. As the factory floor continues to move with mechanical precision, there is another layer most people never see: the control room. Elevated above the production lines, behind reinforced glass panels, engineers monitor the heartbeat of the entire operation. Screens display temperatures, moisture percentages, pressure readings, conveyor speeds, motor loads, and energy consumption. Every machine is connected. Every stage is tracked in real time. One imbalance in moisture during drying, one overheating motor in the milling section, one delay in fermentation timing, and thousands of kilograms of product could be compromised. Cassava processing at this scale is not just agriculture meeting machinery. It is data meeting discipline. Back on the production floor, the drying chambers operate continuously. Heated air flows through stainless steel ducts, evenly distributed to avoid hot spots. Industrial fans rotate with deep, steady force. The air inside these chambers is carefully calculated. Too humid and the product will retain moisture. Too dry and static electricity can affect fine flour particles. Operators check moisture meters frequently. A small handheld device inserted into the product confirms whether it has reached the safe threshold for storage. 10 to 12% moisture is the golden range. Anything higher invites mold. Anything lower risks altering texture. In the Gari roasting section, the human element becomes even more visible. Massive circular pans sit over gas or diesel-powered burners. The heat radiates intensely. Workers rotate in shifts because standing over roasting pans for long hours demands physical endurance. Stirring must be constant. The movement is rhythmic: forward, back, circular, scrape, lift, turn. This motion prevents clumping and ensures even roasting. The sound of granules brushing against metal creates a steady whispering scrape. Steam rises in waves as remaining moisture evaporates. The color slowly transforms from pale white to cream, and sometimes golden, depending on customer preference. Each batch is judged by texture between the fingers. Too soft means underroasted. Too hard means overdone. This judgment comes from experience, sometimes passed down through generations. Even in the largest factories, some skills remain human. Meanwhile, in the flour milling section, the atmosphere changes. Fine particles float lightly in the air before being pulled into controlled ventilation systems. Dust control is essential here, not only for hygiene but for worker safety. Air filtration systems operate constantly to reduce inhalation risks and prevent combustible dust accumulation. Flour passes through multiple roller mills, each stage refining the particle size further. After milling, the powder moves through sifters, large vibrating mesh screens that ensure uniform fineness. Any coarse granules are sent back through the mill again. Consistency defines premium product. In the starch extraction area, the science intensifies. The milky starch slurry moves through hydrocyclones, conical devices that use centrifugal force to separate fine starch particles from water and impurities. The spinning motion inside these machines is powerful yet precise. Heavier starch settles outward while lighter impurities move away. The purified starch suspension then flows into dewatering centrifuges that spin rapidly, removing excess moisture before final drying. The flash dryer blasts hot air into fine starch droplets, evaporating water instantly and leaving behind a fine white powder. The transformation is almost invisible but technically complex. Starch quality must meet strict international standards. It is used in baby food, noodles, baked goods, pharmaceuticals, and even in the coating of tablets. Laboratories within the factory test starch viscosity, pH levels, granule structure, and whiteness index. Nothing is assumed. Everything is verified. Outside the main production halls, another critical system operates quietly: waste management. Cassava processing generates peels, fiber, wastewater, and organic residue. In modern facilities, peels are not discarded carelessly. They are collected, dried, and converted into animal feed. Fibrous byproducts are compressed and sold to livestock farms. Wastewater passes through treatment plants where solids are removed and biological treatment reduces organic load before safe discharge. Some advanced factories even convert organic waste into biogas using anaerobic digesters. This biogas can power parts of the facility, reducing energy costs and environmental impact. Energy management itself is a constant challenge. Running industrial motors, dryers, and presses requires enormous electricity. Backup generators stand ready in case of grid failure. Fuel tanks are monitored closely. Energy efficiency programs aim to reduce waste because lower operational costs mean more stable pricing for farmers and consumers. Inside the packaging section, automation dominates. Vertical form-fill seal machines shape plastic film into bags, fill them with precise quantities of product, and seal them in seconds. Sensors detect improper sealing instantly. Faulty bags are rejected automatically. For bulk buyers, 25 kilogram or 50 kilogram sacks are filled using calibrated weighers. Each bag passes over a metal detector to ensure no foreign object contamination. After sealing, bags are coded with batch numbers linked to production records. Traceability is critical. If a recall is ever needed, the factory must identify exactly when and where a product was made. Finished bags move along conveyor belts toward palletizing stations. Robotic arms in some facilities stack bags in perfect formation. In others, workers manually arrange them with careful precision. Sometimes problems occur. Machines break down unexpectedly. Harvests arrive late. Power outages interrupt production. These moments test the resilience of the entire operation. Maintenance teams rush to repair motors. Backup generators roar to life. Supervisors reorganize shifts to recover lost time. In those stressful moments, the factory proves what it truly is: a community of people solving problems together. Innovation also continues to shape the future of cassava processing. New technologies aim to reduce waste, increase efficiency, and improve product quality. Researchers are developing better cassava varieties that produce higher starch yields. Engineers design machines that process roots faster while using less energy. Environmental systems are being introduced to recycle water and convert organic waste into renewable energy. The industry evolves because demand continues to grow. As populations increase and global food systems adapt, cassava remains one of the most reliable crops on Earth. Its resilience makes it essential for food security in many regions. Yet even with all this progress, the essence of cassava remains simple. A root grown in soil, a harvest carried by hands, a product shared on tables. Inside the factory, the final shift of the day begins to wind down. Some machines slow slightly as batches complete. Workers wipe down equipment, preparing for cleaning cycles. The warehouse doors close behind another departing truck loaded with finished products. The long journey from soil to shelf continues beyond the horizon. For the workers leaving the factory tonight, tomorrow will begin the same way. The trucks will return with fresh cassava roots. The washing drums will start turning again. The graters will roar back to life. The dryers will heat up. The roasting pans will glow. And another cycle of transformation will begin. Because behind every product we use in our daily lives, there is always a deeper story. A story of effort, patience, risk, and human dedication. Cassava may appear ordinary, but the journey it travels is anything but simple. From quiet farms to roaring factories, from raw roots to packaged goods reaching homes and industries around the world, this is the hidden path that most people never see. This is the journey from soil to sustenance. This is the human story behind the product. And if you've stayed with us until the end of this journey, thank you for taking a moment to see the work, the people, and the process that make everyday essentials possible. If you enjoy uncovering the real stories behind the products that shape our world, subscribe to Behind the Product and join us again as we step inside more factories, industries, and hidden processes that keep our world moving.